Definition first. So our altitude of a triangle is a segment that is perpendicular from the center or the vertex to the opposite side. A segment that is perpendicular from the vertex to the opposite side. An orthocenter, that's an O. It's a big hole punch O kind of, right? It's a common point from three altitudes. And I might give you a way to remember this today. Let's see. Did I write it? I didn't, but I will share that with you. So let's go ahead and name the triangle ABC. So how many lines or how many segments do I need to create an intersection? Just two. Just two. If you want to make more than two, go for it. But I'm not going to do more than two. All right. So for the altitude, it just needs to drop down from the vertex straight down. So if you want a free hand draw, go for it. But I am going to be perfect. There you go. So I'm going to touch my vertex A and my opposite that is perpendicular. So for my opposite is CB. And there's my altitude. Let's call that X. Oops. And then let's go ahead and make another one. I can either use AB or AC. I'm going to see if AC is going to work. AC from angle B, opposite that is perpendicular. Would AB work better? Oh, AB is going to work out better, so I'm going to use AB. So here's our C. That's an awkward position. Let's move it. So make sure you're hitting vertex C and then opposite end that is perpendicular. So you guys see it is perpendicular right here because I have a right angle and it's hitting our vertex A. And if it's off a little, human error is perfectly fine. Now, it doesn't mean you have to make the same one from vertex C. You can make it from vertex B or A, doesn't matter. And let's call that point Y. So here's our X and Y. And let's go ahead and call this common point P. And this right here is called the orthocenter. So let's write something on this one. So I gave you an acute triangle just now. This big triangle is acute triangle. And our orthocenter happened to be inside, outside, or on? Inside. It is in the inside. And with that logic, what would happen for the obtuse? It's going to be on the outside. Now, where you put on the outside really doesn't matter. But specifically, it's going to be somewhere over here. But the bottom line is just know it's on the outside. Now, for the right triangle, because orthocenter has to do with the right angle, where do you think it's going to lie exactly on? On the right angle. Because I know that is one line, two line, concurrent point is that intersection. So let's write it's on the right angle.
Oh, because
it is the orthocenter, altitudes. For equilateral is as specific as it could get, so it has to be right in the middle. You could say center or the inside, but center is being more specific. All right, let's go on to our next definition. And I believe this definition will be our last one for our points of concurrency. So median of a triangle is a segment from a vertex to the midpoint. And that common point is going to be called a centroid. So let me wait about 30 seconds-ish. And I know the word median sounds like the midpoint. It is part of it, but not all just the midpoint. It has to do with the vertex. Ooh. Are you adding music to my recording?
Yes.
Stop it. Good try, though. All right. let's make our medians. For the medians, I think I want to make 3 of them. And yes, I'll start with 2 and see how the third one is going to connect to test our point. So let's pinpoint the middle of CB. And then notate. And I'm going to call that point X. Let's go ahead and connect A to X. Oh, that was a little off on the vertex. There we go. So medians from the vertex to the midpoint on the opposite side. Now let's do AB. So pinpoint the midpoint of the AB. 2 tick marks. And I'm going to call that Y. And let's connect from the vertex to Y. And because there's a formula involved in this one, I am going to make our third segment. Yes, ma'am.
Would the vertex be C? Because when you flip the triangle, that's the highest point?
That's the highest point, yes. So what she was saying was when I flip it over, that's the point right above.
Okay.
Okay? So rotate as you need. And maybe some of you guys do not need to. Okay, let's pinpoint the middle of AC this time. And if, let's call this Z. When you connect B to Z and it goes through that intersection, that means you're just perfect. And if it's not, it is okay. So let's go ahead and connect. I wish I was perfect, but who knows, right? Oh. Whoa, what just happened? Oh, I'm so good. I just can't. Now, let's say yours did not go through exactly in the middle and made a tiny little triangle, right? Put a big fat dot and hide it. It's okay. It's like a Band-Aid. Just go, it never happened. Peekaboo.
I have a ruler, so I know mine not perfect. I measured.
You measured. Even better. She's trying to be out better than me. I can't. Good job.
It looks exactly like this.
You know? I just can't. All right. So we know this point right here is called a centroid. And we're going to write some equation that has to do with this. So let's go ahead and write out some things. My centroid, and I want to go ahead and highlight only one of my median, CY. Does that mean there's only one median in this triangle? No. So let's write out something in specific. CY that I highlighted is a median. And it is a median because a Y is a midpoint from the vertex C. And the reason why I'm writing out the median and the midpoint is when I say median, some kids want to say it's the same thing as a midpoint. They're not. Midpoint is the center of a segment. Median is from the vertex of that segment or that point. So let's go ahead and write out more things right here. Here's my vertex, vertex C. Here's my midpoint, because there's a formula involving these 2 points. Now, just by looking at this, would you agree that CP is greater than PY? All right. So then if I go ahead and divide CP exactly in half, what does it look like from these 3 segments right here? They are congruent. And that's a given fact because of our centroid. So I'm going to write out one generic example. CP is 2/3 of CY. So CP is 2/3 of the whole thing. Is that true? Another way I can think about it is the following. PY is half of CP. Or I could say PY is 1/3 of the whole thing. So whichever direction you're looking at, it could be 1/3, it could be 2/3, and so on.
And the same goes for all of them, right?
All of them, yes, but I want to emphasize only one of them. Okay. If you look at it from here to here, cut this in half, then we have 1/3. If I look at it from here to here, cut that in half, then we have 1/3. But I'm only highlighting one because when you highlight too many, our brains just shut down. Yes, ma'am.
So it's not just CY.
It's not just CY. I'm just emphasizing that specific highlighted figure. All right, let's go on to the back. On the back, let me have Parker, read. And we're looking at example number 3.
A triangle ABC.
Is that 3? 1. Oh, look at the staple. Is it off a little bit?
It's off completely.
Oh, let's go to the actual number 1.
A sculptor is shaping a triangle piece of iron that will bounce on the point of a cone. At what coordinates will the triangular region bounce?
All right. The word balance that I should have mentioned something real quick. Let's go back to the picture. Now, let's say you have tray of lots of food. All right. Just assume you're working at a restaurant. And typically, what shape is the tray typically if you're thinking about a restaurant? It could be a circle. It could also be an oval. It could also be a rectangle. Let's say I have a weird restaurant, and that restaurant only has triangular tray. This centroid is a point of gravity, meaning that's exactly where your hand must go so nothing falls. So if you want to, let's write out something on the side that I should have mentioned. This is a point of gravity. And we need that to answer question number 1 that I did not mention at the beginning. That's my little oopsie. So let's go ahead and write out the following. So when something is balanced, it is the centroid. And that's our point of gravity. So I want to go ahead and write out. I need to find out which vertex to which midpoint. And it really doesn't matter which one to, but there are clever ones to look at. So let's name the triangle given to the right. Let's call it ABC per usual. So I can use vertex B to the opposite, vertex A to the opposite, or C to the opposite. Now, one thing that will be silly on your end, if you use vertex A, you see my midpoint is not a clean number? You don't want that. Now let's look at vertex B. When I go to my opposite, is my midpoint a clean number? Let's use that. Does that mean I can't use vertex C? Can I use vertex C and find that clean midpoint? Although that midpoint is kind of in the half, I want to avoid it. All right? So you think about which point is going to give me the cleanest midpoint and then go with that one. So let's write, here's my vertex. Here's my midpoint. And let's call this midpoint D. And just by looking at the midpoint, we know the order pair is 7, 4. So let's do a visual. On our visual, our endpoints are my midpoint to vertex. You can reverse that order if you want to. And our specific number is 7, 4 and 10, 7. And that's just by the given. And we know it's got 3 equivalent segments. So let's go ahead and notate that. And then we know our centroid. Is my centroid closer to the midpoint or closer to the vertex according to our picture?
Closer to the midpoint.
It's closer to the midpoint. So let's write something down. So our centroid on the front, it is closer to the midpoint. So let's write it is closer to the midpoint. And just by looking at it, midpoint is Y, the centroid is closer. Midpoint is X, it is closer, and so on. So let's go on to that problem one more time. So on this problem, it is closer to the midpoint. So we know just by looking at our 7 and 10, how many units is it away right now? 3. So this must be representing 1. That must be 1. That must be 1. So that means our centroid must have the X coordinate of what? 8. Now, is that pretty consistent on the Y value too, from 4 to 7?
Yeah.
It doesn't mean they're always the same, all right? So then we know instead of 7, 4, this is going to be 8, 5, and that's our final answer. Yes, ma'am.
What can you draw out the other?
You can draw out the other, but then our midpoint is not a clean point. That happens to be half. And this also happens to be half, but this is a clean number. So you can if you want to. Okay, yes, sir.
I know that they aren't clean numbers, but if you just drew them out,
It'll still work out.
yeah, but
It
there
will-
wouldn't be any need for numbers. You just look at point.
Good point. I'll take that. I'll take it the way you see it, but I'm going to look at this right here for a concrete example. Okay? All right, let's go on to example number 2B and make sure you know this topic very well. So, Bobby, let's read the instruction. 2B?
Determine if each of the following statements are true or false. If CF parallel to ED, then CF is an altitude of both triangle ECB and triangle EC.
So let's see if that is true. It says CF. I'm going to highlight that with my red pen or make it thick. If CF is perpendicular from ED, let's see if it is true for both the triangles. So I'm going to highlight the first one with one color. Here's one color. So is CF really the altitude of that triangle?
Yes.
Yes, it is. So I'm going to say, all right, we're happy with this one. With my second color, I'm going to now highlight EC, what was it? ECG. So ECG is right here. Is that also the altitude of that tiny triangle?
Yes.
Yes, it is. So is this true or false?
True.
It is true. So since there's so many triangles within, if you would highlight them, it'll kind of pop out a little bit, and I think it'll be easier. All right, let's go on to the back.
To the front.
By the back, the front, the weird stapled manner. All right, so on example number 3, it looks like our letters are not really there, so let's go ahead and rewrite the letters. Some of them might be kind of evident, right? No? Oh, that's a no. So just by looking at this, the fact that we have the midpoints on all of them through the vertex, we have a centroid. And let's see the givens. FB is 21. So if I know F to B is 21, can I go ahead and split this right here? And I know these three are all congruent too. So what can I say about OB then?
They're each. Oh, that's 14.
Yep, they're all 7, so therefore OB must be 14. Oh, and that's only if you know the given fact about the centroid. The next one says to find AE, so let's notate everybody else. OE is right here, which is 4. So I can go up and make a third again. So if that is 4, we have 4 over here. So how many is our length of AE?
12.
12. AE is a whole length.
It's not A.
Yes, ma'am.
Do you have to draw the lines above
OB.
like the
What do you mean lines above the OB?
congruence?
You can. I don't want to put 4 tick marks and 5 tick marks.
Oh no, like sometimes you draw like the OB and then like a just
Line
so
over,
it's-
line over the.
or sometimes
the
an
segment.
arrow, sometimes.
Oh, can you further extend it?
No,
So
so
it's
if
a
you
line
write
segment.
OB, you usually put like a line segment over.
That's if it's a picture. So I'll write over here. So numbers are so this will be a measurement. So it'll just be 14. But when I say OB, that will be congruent to some other segment. So you're being very specific, which I like. Okay? All right. Let's move on to example number 4. Is 4 one of the ones that I want to do? Let me make sure. Centroid. Nope. Let's go on to example number 5. Okay, on example number 5, we know our fill in the blanks. True or false always happens on our assessments. So blank is a point where 3 altitudes intersect. Orthocenter. And that was a definition defined on the front of the page. And then our next one, we have another true or false. So just by looking at this, it says G is a midpoint of ED, so 1 tick mark each. And then we know that CG, let me make that bold, is the median of the whole triangle EBD. I would say it's partially true, but not exactly. What would make this true? If that was a vertex, and right now it is not the vertex, therefore it's not the median. And there's one more question that I skipped that I want to go over before we look at an acronym I'm going to teach you guys. All right? So let's go to example number 2. Okay, on example number 2, it says to find the altitude. From which point? Point B. So let's go ahead and put on here point B, vertex. Shepherd question.
Are we sure that's point B and it's not asking about another point because the graph doesn't label the points?
Yeah, it doesn't, and I'm going to label it for you. So here's our A, B, and C. And I'm only doing that because it's the same picture from right above, so why not be consistent on the bottom, okay? And yes, that will be labeled on your assessment, always. All right, so from here, we need to first figure out, just by looking at this, find the altitude of the triangle. And when we're looking for the altitude, what is the first thing that we have to actually do?
On the opposite side.
Find the opposite side. And let's go ahead and call this one AC. So if it's an altitude, then we need the opposite side has to be perpendicular. Is that right? So I need a perpendicular to AC. So let's find the slope of AC real quick. Our slope of AC clearly is going down. Is that right? And if we do rise over run, how many is it going down across how many? 2 over 1. And then we want the perpendicular slope, which has to be how many? 1 over 2. Opposite sign and reciprocal, flip the fraction. And then we want to use point slope formula. And on our point slope formula, the point we're going to use is 10, 7. Let's call that x1 and y1. And didn't we do a question with the point slope a while ago? Yep. So here's a reminder in case you forgot. Point slope formula. And this equation starts with y minus y1. And I want you guys to complete this. What goes after? M times x minus x1. And when I plug it in, we get y minus 7 is equal to 1/2 x minus 10. And let's do our tedious math by distribution. And then half of negative 10 is 5, or negative 5 specifically. So our final answer, y is equal to 1/2 x, how many? Plus 2. And let's actually graph this to make sure it does work out. Starting at 2. We're going to go up 1 over 2, up 1 over 2. And when I do connect this with a straight edge, do we see that it is perpendicular through the point B? Yep. All right, did I miss any other page or parts? This one I'm not going to worry about. All right, let's talk about a way to remember our circumcenter, incenter, orthocenter, and centroid, because it is confusing, right? It's a lot. So a former teacher of mine actually came up with the following phrase. Y'all ready? How many of you guys like peanut butter?
Sticky, gross.
Gross? All right, you're going to have to like it for this unit, all right? Let's write this piece. Crunchy peanut butter in that one line is always best, second line. On a third line, cold morning. Everybody write this so you don't miss it on your quiz and test. Right. Thank you. And we'll talk about what they stand for. So we got crunchy peanut butter is always best on a cold morning. Did you guys also underline each letter? Okay.
Do you want us to do the dashes under the D again?
You know, that would be a good idea. And if y'all like saying morning with morning, that might be even better for a reason, okay? That's just my preference. All right, are we ready for what it means? Okay, listen carefully. Circumcenter is created by 3 perpendicular bisectors. Circumcenter, perpendicular bisector. Second one. Incenter is created by 3 angle bisectors, as in AB, angle bisector. Again, incenter, created by 3 angle bisectors. Y'all ready for the third one? Not yet? Not yet. Okay, on my third one is what we did today. Orthocenter is created by 3 altitudes. Orthocenter by 3 altitudes. And the last one, centroid, created by 3 medians, and there's a reason why I underlined the D and the N. Centroid starts with a C and ends with a D, in case you forget. Median starts with the M and ends with an N. So for this class, our morning is morning. All right, if that helps you. Is everyone clear on that? That's a way to remember them.
What was that?
What was the first one?
The first one was circumcenter, perpendicular bisector.